Hi everyone, welcome to Mathworld. This video is to discuss the Cambridge International AS and A-Level Mathematics Paper 5, which is a Probability and Statistics 1 for May-June 2023, and the code is 9709/53. Okay, so let's move on to question number 1. Number 1, two fair coins are thrown at the same time repeatedly until a pair of heads is obtained. The number of throws is denoted by x. A state the value of EX. So from here, since we need to get until a pair of heads is obtained, means that this is geometric distribution. Okay, so now, since this is fair coin, so a PH will be 1/2. H is to represent the head. So now P pair of heads means that double H, it will be 1/2 times 1/2. Then I will get 1/4. Okay, and since this is geometric, with the probability of 1/4, now EX for geometric, if you still remember, X is geometric with probability P, EX will be 1/P. Okay, that means now you will get 1 divided by 1/4, which is 4. Okay, now B, find the probability that exactly 5 throws are required to obtain a pair of heads. That means now you have first 4 are failures. Okay, another one you will get double H. So from here, so since P double H will be 1/4, that means not getting double H. Okay, not getting double H, it will be 3/4. Alright, so from here, it is still geometric. This is still geometric distribution. That means now your probability will be, I will have 4 failures. Alright, so this will be the Q. Okay, so that means this is a Q. So now 4 failures means 3/4 to the power 4, and then 1/4 to the power 1. 1 success, 4 failures. So you will get 81/1024. So you can leave your answer in this form or in decimal, which is 0.0791. Okay, now C. Find the probability that fewer than 7 throws are required to obtain a pair of heads. That means now Px less than 7. So when Px less than 7, it will be x up to 6. Alright, and again for geometric distribution, when your x is geometric, P, so when Px less equals to small x, it will be 1 minus q power x. So now, remember that your P is 1/4. Okay, your P is 1/4. That means your Q is 3/4. And now substitute into this formula, it will be 1 minus 3/4 to the power of 6. Then you will get 3367 over 4096. Alright, or correct to decimal places or significant figures, it will be 0.822. Sorry. Okay, now for question 2. Anil is a candidate in an election. He received 40% of the votes. A random sample of 120 voters is chosen. So N equals to 120. Then the P is 0.4. Now use an approximation to find the probability that out of 120 voters, between 36 and 54 inclusive, voted for Anil. So it means that now here, since your N is the voters, number of voters, means that this is binomial distributed. Okay, because it is discrete. So I will write 120, 0.4. Then now, since your N is large, that means, and it's given the hints here as well, you need to use approximation. So we need to get the NP and NPQ. And this will be approximate to normal. Alright, so it will be 120 times 0.4, and you will get 48. Then the NPQ, since the NP already counted, which is 48, so I just replace it by 48. Now, your P is 0.4, that means your Q is going to be 0.6. Okay, so here 0.6. So it will be 28.8. Okay, so now here I will approximate to normal distribution, which is 48. Mean is 48, and standard deviation, this is variance, and variance is 28.8. So now you need to count probability that the voters between 36 and 54 inclusive. So this word is very important. So now P, 36 and 54 inclusive. Okay, so when you look at the question, initially you were given binomial, which is discrete random variable, and now you approximate to normal, which is the continuous random variable, which means you need to consider the continuity correction. So now here I have two values, 36 and then 54. And greater equals to 36 means that it will be 36, 37, and so on. Okay, and up to 54. So it can be 54, 53, and so on. Then now I need to decide whether I plus 0.5 or minus 0.5 from these two given values. So if I minus 0.5 from 36, I will be getting 35.5. But if I plus 0.5 from 36, it will be 36.5. Same goes to the 54. So I minus 54, I minus 0.5 from 54, it will be 53.5. And I add 0.5 to 54, it will be 54.5. Okay, so obviously to include the ticks, I have to choose the wider range or wider interval. So that means it will be from 35.5 until 54.5. Okay, then from here I will standardize on the normal random variables by using 35 minus 5. Okay, which is the formula. This is the formula. You minus the mean is 48, over square root of the variance, 28.8. Then here is z, for 54.5 minus the mean, 28.8, over the square root. Okay, so from here you need to count these two values and you will get negative 2.329 and 1.211. So once you get this, sketch a graph, normal graph. One is negative 2.329, another one is positive 1.211. Okay, so from here it will be pz less than positive value minus pz less than negative value. So for the negative value, we can't get this from the table. Therefore, you have to draw another or sketch another graph for the negative value. This is pz less than negative 2.329. So the negative value here is negative 2.329 will be reflected. Okay, because it's negative value, the critical value should be positive in order to use the table. So now I will reflect it to the positive 2.329, which is here. Then now to get this blue region, it will be total probabilities, which is 1 minus less than the positive value probability. Okay, then here I will write p z less than 1.211 minus 1 minus p z less than 2.329. Then now you can get the probabilities from the table. So from the normal table, the first value is 0.8871 times in the minus, it will be minus 1 followed by plus 0.9900. Then at last you will be getting 0.8771, and now round up to 3 significant figures, that will be 0.877. Okay, now the next question is number 3. The random variable x takes the value 1 until 4 is given p, the probabilities equals to kx times x plus a, where k and a are constants. A, given that probability of x equals to 4 is 3 times the probability of x equals to 2. Find the a and the k. Okay, so from here, I will start with px equals to 4 equals to 3 of px equals to 2. So when px equals to 4 means that now you have to replace the x by 4. Okay, so I will get k bracket 4, then 4 plus a equals to 3 of, when px equals to 2 means that here is 2, then replace the x by 2. So I will get k bracket 2, then 2 plus a. Okay, so from here, when you do the expansion, it will be 4k, 4 plus a equals to 3 times k times 2, it will be 6k, then 2 plus a. Okay, so now do expansion again for both sides. So 4k times 4k times 4 will be 16k. So 4k times a, it will be 4ka. Right hand side, when you do expansion, it will be 12k, then plus 12, plus 6ka. Okay, so basically the k can be cancelled off for all, alright? So I didn't notice that. Means that I can just ignore all the k. Then we can reduce the variable. So I can cancel out from both sides. Alright, that means now when I do expansion, it will be 16 plus 4a, then equals to 12 plus 6a. So move the a to the right hand side and move the constant to the other side. So I will get 6a minus 4a, it will be 2a. Then by moving the 12 to the other side, it will be minus 12. So 16 minus 12, it will be 4. So at last, your a will be 2. Once we get the a, then we need to count the k. Okay, so since a k is a constant, that means I am going to use the total probabilities equals to 1. So now, total probabilities equals to 1. Okay, so now your px equals to small x is basically kx bracket x plus 2. So now your x will be 1, 2, 3, 4. So now I will write, okay, your k is in common. So k is in common, I can take it out. So when I consider x equals to 1, here is 1, then 1 plus 2, it will be 3. Plus with, when x equals to 2, because my next x is 2, then I will get 2 bracket 3, because 2 plus 2 plus 2, 2 plus 2 is 4. Now, when my next x is 3, so here you replace by 3, replace by 3. That means I get 3 bracket 5, then plus, when the x equals to 4, so 4 bracket 4 plus 2, 6. And this is going to be 1. Alright, so when you add up the values inside the bracket, it will be 50. Then I will end up with 50k equals to 1. Hence your k is 1 over 50. So that's the solution for A. Now B, draw up the probability distribution table for x, giving probabilities as numerical fractions. Okay, so now I will rewrite my P. Probability x equals to small x. So we have found the A and K just now. Okay, so now when you refer back to when you substitute back into your probabilities, your K is 1 over 50. So I'm getting 1 over 50 x bracket x plus 2. That will be my probabilities. And remember, your x will be 1 until 4. I will write 1, 2, 3, 4. Okay, so now when px equals to 1, it will be 1 over 50, 1 times 3. So 3 over 50. When px equals to 2, it will be 1 over 50, bracket 2 plus 2 is 4. So I will get I will get 8, because 4 times 2 is 8. 8 over 50. Then when px equals to 3, it will be 1 over 50 times 3, then 3 plus 2, it will be 5. I'll get 15 over 50. Then when px equals to 4, it will be 1 over 50, bracket 4 times, when x is 4, 4 plus 2 is 6. So it will be 24 over 50. Okay, so now we need to get the table. So just put all this in table. When x is 1, 3 over 50. When x is 2, 8 over 50. Okay, so just replace. When 3, you get 15 over 50. When 4, you get 24 over 50. So one way to check whether this table is correct or not is to get the sum of the probabilities. Make sure the total probabilities here is 1. Okay, so we have solved this question. Now see, given EX is 3.2. Find variance X. So now we need to get EX squared. So EX squared is summation X squared P. X. So now you square all the X here. I mean you square the X and then multiply with the P plus with another pair of the values. So 1 times 3 over 50 plus 2 squared times 8 over 50 plus 3 squared times 15 over 50 plus 4 squared times 24 over 50. Okay, then from here you will get 277 over 25. Then now we can find the variance X. So the variance X is basically EX squared minus square of the mean, which is 277 over 25 minus the mean is 3.2. Then you square it. And then at last you will get the answer. So I will leave my answer in fraction, which is 21 over 25. Alright, so that's the solution for this question. Now for question number 4, the times taken in minutes to compare or to complete a cycle race by 19 cyclists from each of the 2 clubs, cheetahs and panthers, are represented in the following back-to-back stem and leaf diagram. So look at the key here, 7/9/1. So if 7/9, which is here, it means 97 minutes. Okay, 9/1 means that it is 91 minutes. Now the first one is for cheetahs and the second one is for panthers. Now find the median and interquartile range of the times for cheetahs. Means that now, okay, we know that total is 19, n equals to 19. So the median is half of 19 plus 1 theta. That means it's 20 divided by 2, which is theta number 10. Alright, so now I will label. Where is the theta number 10? Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So obviously it's 99 minutes. Okay, and for interquartile range we need to get Q1 and Q3. So Q1 is 1 over 4 of the total. So 19 plus 1 is 20. 20 divided by 4 is 5. Theta number 5. So by referring to the labeling, I will get 83 because that is the number 5. So 83 minutes. Okay, and then the next one is Q3. Q3 is 3/4 of 20. So 3/4 you will get theta number 15. Theta number 15, then I have to continue labeling. This is 11, 12, 13, 14, 15. So theta 15 will be 106. So now interquartile range, it will be Q3 minus Q1. That means 106 minus 83. Then you will be getting 23 minutes. Okay, so that's the solution for A. Now, the median and interquartile range for panthers are 103 minutes and 14 minutes respectively. Make 2 comparisons between the times taken by cheetahs and the times taken by panthers. Okay, so from here, since you are given the median, so we will compare the medians and also compare the interquartile range. Okay, so now your median for the cheetah is 99. Look at here, 99. This is a median. This is 103. That means the median for pandas is bigger. Alright, so now I will write. The first one is median of cheetahs is less than median of panthers. Okay, so that means cyclists from cheetahs can complete the race faster compared to panthers, because panthers needs more time. So complete the cycle race faster than cyclists from panthers. Okay, that is the first comparison. Second comparison is on the interquartile range. So now you look at the interquartile range here. For the cheetahs, it will be 23 minutes, but for panthers, it's only 14 minutes, means less spread for panthers because less value, okay, smaller value. So IQR, interquartile range, of panthers less than interquartile range of okay, probably I can just define here. Interquartile range means the IQR. There I do not need to write so much. So here, IQR of panthers less than IQR of cheetahs. Okay, means the times for panthers, for cyclists from panthers are less spread, because the interquartile range is the measure of the spread. Okay, then cyclists from cheetahs. Okay, so these are the two comparisons regarding the median and the interquartile range. Okay. Now another cyclist, Kenny, from the cheetahs also took part in the race. The mean time taken by 20 cyclists from the cheetahs was 99 minutes. Okay, just now initially was 19. Now add with the additional of Kenny, additional participation of Kenny, then it becomes 99, the mean. So now find the time taken by Kenny to complete the race. Okay, so when n equals to 20, the mean time is 99. So from here I can say that the total time taken by 20 cyclists, it will be 20 times 99, which is 1980 minutes. Okay, so now to get the time taken by Kenny, I need to get the total time taken by 19 cyclists. So total time taken by 19 cyclists, I need to add up all the data in the back-to-back sine wave diagram. So it will be, I will just list out some. So it will be 78, 79 plus until 124. Okay, so I will write here 78 plus 79 plus until 124. So this is going to be 1862. So from here, the time taken by Kenny, you just minus. Okay, it will be 1980 minus 1862. So at last you will get 118 minutes. So all these are minutes. Okay, so this is how we solve this question. Now question number 5. Jasmine throws 2 ordinary fair 6-sided dice at the same time and notes the numbers of the uppermost faces. The events A and B are defined as follows. A. The sum of the 2 numbers is less than 6. B. The difference of 2 numbers is at most 2. So now A, determine whether or not the events A and B are independent. So now since this is 2 6-sided fair dice, then I will draw a table to show the values, to show the possible outcomes. So here 1, 2, 3, 4, 5, and 6. Let's say this is dice A. Okay, then don't want to use A because you are given the events A, B. So this is dice 1, this is dice 2. Then here 1, 2, 3, 4, 5, 6. Alright, so now I will label directly because you need to decide whether A and B are independent or not. So just for information, if A and B are independent, means that A intersects B, probability equals to PA times PB. Okay, this is how we prove the independent events. So now A, the sum of the 2 numbers is less than 6. So I will label the value as A. Okay, so 1 plus 1 is A, less than 6. So 1 plus 5 is 6. That means the rest will be A. So 2 plus until 3 will be less than 6, the total. 3 plus 1 is 4. 3 plus 2 is 5. 3 plus 3 cannot, the rest cannot. So 4 plus 1 is 5. 5 plus 1 is 6. So no more elements of the A. Now B, the difference between 2 numbers at most 2. At most 2 means maximum 2. So it can be 0, can be 1, can be 2. So now 1 minus 1 is 0. It will be B. 2 minus 1 is B. 3 minus 1 is 2. It's also B. So 2 minus 1 is 1. I get B. 2 minus 2, 0. I get B. 2 minus 3 or 3 minus 2 is B. 4 minus 2 is 2. Okay, 3 minus 1 is 2. That means it's B. 3 minus 2 is 1. So B. 3 minus 3, 0. 4 minus B. 4 minus 3 is 1. 5 minus 3 is 2. Okay, then 4 minus 1 is 3. Cannot. 4 minus 2 is 2, which is B. 4 minus 3 is 1, B. 4 minus 4 is 0, which is B as well. Then 5 minus 4 is 1, B. 6 minus 4 is 2, so I get B. Now, next one is 5 minus 1, 4, cannot. So I will start with from the back. 6 minus 5 is 1, which is B. 5 minus 5 is 0, B. 5 minus 4 is 1. 5 minus 3 is 2. Okay, then the 6, I will start with the 6. So 6 minus 6, 0. 6 minus 5, 1. 6 minus 4 is 2. 6 minus 3 cannot, right, which is 3. So these are the outcomes. Okay, so I don't want to list down, that's why I use the table. So now I need to count what is my A intersects B. probability. So A intersect B means that you will see the A and B at the same time. That means it will be 1, 2, 3, 4, 5, 6, 7, 8. Alright, so you are getting 8 out of 36. Why 36? Because the first dice has 6 outcomes, second dice has 6 outcomes. So 6 times 6, 36. So I'm getting this 8 over 36. Now PA, it will be, just count the green color, how many A's here. First column 4, second column 3. So 4 plus 3 is 7, 7 plus 2 is 9. Then together with this, it will be 10 over 36. Then the PB. PB means we count how many B's. So first column 3, second column 4, total is 7. So you just add up all the number of B's, you will get 24. Now I need to count PA times PB. It will be 10 over 36 times 24 over 36. And then at last you are getting 5 over 27. Alright, so obviously it is not the same as the PA intersect B. Now, basically the PA intersect B, 8 over 36, you can simplify into 2 over 9. So from here I will write it is not equals to PA intersects B. So when independent, they will be equal. But now since they are not equal, that means the conclusion is they are not independent. So now A and B are not independent events. Okay, so that's the solution for A. Now part B, calculate P probability of B slash A prime. So now I will write P B slash A prime. So A prime means the complementation of A. So now use the formula. Alright, our formula is this. PA slash B, it will be PA intersects B over PB. So now I'm getting PB intersects A prime over PA prime. So B intersect A prime means that those without the A intersect with the B. There are how many of them? So without the A, but intersect with the B. Okay, so without the A means all this. As long as you don't see A, that means those are A prime. Okay, intersect with B means you just count how many of the B without the A together. So all this will be the intersection. So when you count, it will be 16 of them. Okay, so my probability for the numerator is 16 over 36. Now, PA prime is basically 1 minus PA. Alright, so look at here. Your PA is 10 over 36. So now I will get PA prime is 1 minus PA. That means 1 minus 10 over 36. I'm getting 26 over 36. So I will write here 26 over 36. And now the 36 can be cancelled off. Then you get 16 over 26 and simplify it into 8 over 13. So that's the probability of the conditional probability. Okay, that's the probability of this is the conditional probability. Okay, now question 6. The mass of grapes sold per day by a large shop is modeled by normal distribution with mean 28 kg. On 10% of the days, less than 16 kg of grapes are sold. Find the standard deviation. So from here, I will write X is normally distributed. The mean is 28. Standard deviation, I let it be sigma. So the variance will be sigma squared. 10% it is less than 16 kg. So Px less than 16, it will be 10%, 0.1. Then now I have to standardize it. You will get 16 minus 28 over sigma, which is 0.1. And then when you count the value, 16 minus 28 is basically negative 12. Okay, we know that the sigma is always positive. Standard deviation cannot be negative. Then now, this is a negative value because of negative 12 in the numerator. That means my critical line is on the left hand side. Obviously, it is negative value. So the probability of less than this critical line is 0.1. That means here is 0.1. Now, since the critical line is the left hand side is on the left hand side, we need to flip it to the right side before we refer to table. So once you flip, the region will remain the same, 0.1, and the critical line becomes 12 over sigma. So in order to get this green region, it will be total region, which is 1 minus the previous region. Okay, so I will get, or probably you can say this is basically 0.9. Okay, that is the fastest way. So that the total probabilities or total area under the curve is 1. So now I will write PZ less than 12 over sigma will be 0.9. Then now from normal table. Okay, so PZ less than 1.282 will be 0.9. Then now 12 over sigma is 1.282. Then you can get the sigma by moving it to the right side. So sigma will be 12 divided by 1.282, which is 9.36, which correct to 3 significant figures. Okay, now the mass of grapes sold on any day is independent of the mass sold on any other day. 12 days are chosen as random. Find the probability that less than 16 kg of grapes are sold on more than 2 of these 12 days. Alright, so now less than 16 kg, the probability is given in the previous question, which is 0.1. So I know that this is going to be binomial because now you consider the days. Alright, so I don't want to use x because just now x for the mass. Alright, so now your y is n, binomial. The n is 12, then the probability of getting this is 0.1, which is given in the part A. So now find the probability that more than 2 out of these 12 days will be selling this less than 16 kg of grapes. So P y less than 2 out of 12 days. So now for binomial, x is binomial distributed, and P, probability of x equals to small x will be NCX, PX, QN minus x. So when y less than 2 means that Py equals to 0 plus Py equals to 1 plus, that's it, okay, because less than 2. Then now, when y equals to 0 means that all failures, okay, no success. So your P is 0.1 means that your Q is going to be 0.9. So all failures means that there will be 12 failures. Okay, I read the question wrongly. I overlooked the question. This is more than 2. It is not less. It is more. Okay, when more than 2 means that I use, instead of counting 3 onwards, I use 1 minus P less than equals to 2 because it's 3 onwards. So from here it will be Py equals to 0 plus Py equals to 1 plus Py equals to 2. So now 1 minus y equals to 0 means no success. It will be all failures. So 0.9 to the power of 12 plus 1 success. So 12C1, 0.1 to degree 1, 0.9 degree 11 plus y equals to 2 means 2 successes. So 12C2, 0.1 degree 2, 0.9 degree 10. Right? So now you need to count all these values to get the final answer. So here will be 1 minus, if you count one by one, okay, it will be 0.28243. Then the next one is 0.37657. And then the last one is 0.23013. So it will be 1 minus, okay, I just direct count now. I don't want to get the total of the brackets. Then it will be 0.111, correct to 3 significant figures. Okay, now see, in a random sample of 365 days, on how many days will you expect the mass of grapes sold to be within 1.3 standard deviations of mean? Right, let's say for example, this is the diagram. This is the mean. 1.3 standard deviation because it's within. So we are not sure whether it's above or below from the mu. So now you have to consider both. This is 1.3 standard deviation. Here is 1.3 standard deviation, which means this value, okay, these two values is going to be mu minus 1.3 sigma and mu plus 1.3 sigma. And now you need to count what is the probability for this whole interval. So now P mu minus 1.3 sigma, and then this is x, then mu plus 1.3 sigma. Okay, before you get the number of days, we need to get the probability first. Then only the probability multiplied with this 365 days. Now here I have to standardize it. So when you refer to the question here, right? Okay, basically here I can just say x is normally distributed, mean mu, variance sigma squared. Because in this question you are not given the mu and sigma squared. So what to do is when you standardize, we minus the mu and divide by sigma. So basically we do not need the actual values of mu and sigma squared in this question because it will be cancelled off. Okay, so now mu minus mu will be 0. Then minus 1 over 3 sigma over sigma, you will get negative 1 over 3. And the other one will be positive 1 over 3. Now once you get this, I can sketch a graph. Your z between negative 1 over 3 and 1 over 3. That means your region is between these two values. Then I will say that it is, since it is symmetrical at the origin, at the 0, then it will be double of this red color. Okay, so now I will write it is double of the probabilities between 0 and 1.3. So when double means that it can be found using pz less than 1.3 minus pz less than 0. That will be the red color. So pz less than 1.3 minus pz less than 0. Okay, so now pz less than 1.3 from the calculator, from the table, you will get 0.9032. And then pz less than 0 is actually half of the graph, which means half of the area, of the total area, which is also 0.5. Okay, so when you substitute, when you calculate the values inside the bracket and multiply by 2, you will get 0.8064. Okay, here I do not round up to 3 significant figures because this is not our final answer. Our final answer is how many days out of 365 days. So now my number of days it will be 365 multiplied with 0.8064. Then I will get 294.336. But since days cannot be in decimal, then I will just write approximate to 294. 3 decimal places. Okay. So now question 7. Find the number of different arrangements of the 10 letters in the word Casablanca in which the two C's are not together. So from this word, there are some repeating letters. So there are 10 letters. I have 1, 2, 3, 4, 4 A's. And then I have 1 C, 2 C. I have 2 C's. Okay. Then I have S, B, L, N. So these are the 10 letters. Okay, given that the 2 C's are not together. So if they are not together means that you can use the arrangements without restriction minus they are together. Okay, because when you observe the 2 C's, either they are together or not together. So I will write number of arrangements equals to number of arrangements without restriction. Minus number of arrangements when 2 C's are together. Okay, so when number of arrangements without restrictions means that you are arranging this 10. So it will be 10 factorial, but 4 repeating, 4 A's together with 2 C's. Minus when the 2 C's are together. Okay, let's see here. 2 C's are together. Then you still have another 8 letters because total is 10 letters. So out of the 8 letters, you have 4 A's. So now, when we arrange, we do not assume the 2 C's are in the first place. It can be in any of the places. Means that here 8 plus this 1 plus the C's becomes 9. Okay, so I'm arranging 9 letters. I will say this, 9 letters, because the 2 C's, it will be grouped as 1. Then out of the 8 C's, out of the 8 letters, you still have 4 A's. So you must divide by 4 factorial. So from here, when you calculate, the first one is 75600. The second is 15120. Then at last you will get 60480. This will be the number of arrangements when 2 C's are not together. Okay, now B. Find the number of different arrangements of the 10 letters in the word where which has A at the beginning, A at the end, and exactly 3 letters between 2 C's. So now A in the beginning, A at the back, total is 10. Remember, there are 10. They have 4 A's, 2 C's, and exactly 3 letters between 2 C's. So I will say that this is a C. After that, 2 letters. Okay, exactly 3 letters between the 2 C's. So now it will be 3 letters. There will be another C. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is the first arrangement. Now I will say that my first is A, last is A, and my C is in the second place. So then make sure there are 3 letters between the 2 C's. So here 3, after that here C, here 2 more letters. It could be A dash dash C, then 1, 2, 3 dash C, dash A. Okay, and then it could be the C just beside the last A. So dash 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 C dash 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 C A. Alright. So from here, don't forget you still have 2 A's here for all. Okay, because we have 4 A's in the beginning. So now, for the first case, we have to arrange another 6 letters. Out of 6 letters, you have 2 A's. That means the number of arrangements will be 6 factorial because you are arranging 6, the 6 dash. Out of the 6 dash, you have 2 A's, so over 2 factorial. And if you refer to the second one, it's still the same. You have 6 dash. Out of 6 dash, you still have 2 A's, right? Same for the third case, same for the fourth case. Means that now I can just multiply by 4 because all of them will be having 6 factorial over 2 factorial. Then at last, you will be getting 1440. Okay, now 5 letters are selected from 10 letters in the same word. Now see, find the number of different selections in which 5 letters must include at least 2 A's and at most 1 C. Means that minimum 2 A's, maximum 1 C. Now, we have 2 methods to solve this question. The first method is you direct consider. So now I have 10 letters, I have 4 A's, 2 C's. Okay, and the rest. So now I need to choose 5. Okay, then I still have the S, B, L, and N. So from here, I need to choose 5 letters that satisfy this condition, at least 2A and at most 1 C. So from here, I choose 5. So I consider when 2 A's, 1 C. So already 3 letters, I need 2 more. Okay, because maximum 1 C. So if maximum 1 C means that I only have 2 A's, and then I don't have any C, 0 C. Means that now I need to choose 3 letters. Okay, now probably I choose 3 A's, 1 C, 2 letters. Then 3 A's, 0 C, then I have to choose 3 letters. Now, maybe it can be 4 A's. So 4A, 1 C is already 5 letters. Okay, so no need to choose other letters. Maybe 4 A's, 0 C. So when 0 C means that I need to choose 1 more letter. So I need to count the number of selections. Okay, because it's mentioned here, different selections. So now, my number of selections. So for the first case, right, remember we need to get this dash from this 4. So now from 4 I need to choose 2 because 2 dash, 2 places or 2 letters. So 4 choose 2. Or all these are all. Now I need 3 letters from the S, B, L, N. So 4 I choose 3. Or the third case I need 2 letters. So 4 choose 2. And then the fourth case I need 3 letters. So 4 choose 3. The last case, right? Last case, we do not choose any letters, but this is one way. So I plus 1. And then plus, I need 1 letter from the SBLN for C1. Okay? Okay, I check back first. Now I notice that I have done a mistake. See here, 3A, 1C already 4 letters, so I need 1. Alright, 3A is already 3 letters, I need 2, so extra 1. So which means my working for the third and fourth will be different. Alright, so here I need 1, here I need 2. So here 1, here 2. So then, when you calculate each of the values, 4C2 is 6, 4C3 is 4, 4C1 is 4, 4C2 is 6, here 1 plus 4. So the total of this will be 25. This is the working when you direct calculate. At least 2A and at most 1C. Right? So, another method to solve this question is you can just consider the A. So, or at least 2A. So, it can be 2 A's. It can be 3 A's. It can be 4 A's. So, if 2 A's means I need 3 more letters, then here will be 2 letters. This is 1 letter. Alright. So, what I do is from 10, I have 2 C's, 4 A's, and then I have B, S, L, N. Okay, this is the second method. Now, from here, I just consider choosing from B, S, L, N. Alright, that means the number of selections. Okay, now, when you just consider B, S, L, N, you did not consider this condition. So to get at least one C, alright, at least one C means that I have to include the C over here. Means now I add one more C, this one becomes 1C. So out of these 5, okay, I just choose, because at most 1C means that it could be 0C or 1C. So then here I need 3. So I'm going to choose this 3 from this 5. So be careful with this, right? So which means you will get 5, choose 3. Or to get the second case, it will be choosing 2 letters from the 5. And the last one will be 5, choose 1. Okay, then here you will get 10. The second one is also 10. The last one will be 5. Then you are getting 25 as well. See, it's the same answer. Alright, so these are the 2 methods to solve this question. Okay, so we have done this whole paper. Alright, so thanks for watching. Please subscribe to my channel if you think that this video is useful, and stay tuned for more upcoming videos. Thank you. Bye.